Hello there. Welcome. Always great being back in Norway, Oslo. How many of you are from Oslo, by the way? Oh, okay, a lot of you. Okay. It's been a while since I've been back to NDC. For those of you who don't know me, my name's Udi Dahan. Twitter, I'm at Udi Dahan. I work at a company called Particular Software, and we make in Service Bus, but that's not what I'm going to be talking about today. My shtick is microservices and service-oriented architecture, and in general, building complex enterprise-grade software. And my guess is that most of you have already heard of microservices before. Who's heard of microservices before? Yes, okay, that's pretty much everybody. Now, for those of you who know a little bit about me, you know that I tend to take a contrary viewpoint. So if I say something about microservices which is different from what you've heard about before, that's normal. Okay? So what I'm going to be talking about today is a different kind of microservices approach. And then from there, I'm going to be introducing something that my guess is a lot of you haven't heard about for a long time, this thing called rules engines, and seeing how these engines and microservices end up working together to solve a special category of business problem that most people run into when they've already really committed to their architecture and it's kind of too late to make any changes to that. So answer me this. Raise your hand if you've ever had to deal with a feature that didn't really fit with your architecture, and then you told the other stakeholders on the project it would be faster to write the system from scratch than to implement this feature on the current code base. Yes, raise your hand if you've said that before. Okay, this talk is for you. By the way, don't go doing big bang rewrites. They always end in tears, but that's the topic for another talk. So first of all, before getting into the whole rules engine side of things, I want to set the record straight on microservices. Microservices originally was meant to be SOA done right. Another blast from the past. Remember him? Why did we need SOA done right to be rebranded? Because just SOA turned into a big pile of crap that everyone's like, I don't want to do SOA. It's crap, it's heavyweight, it's complex. Microservices, they're small, they're agile, they're fun. So rebranding is something that we tend to do a lot of in this industry. Roughly every 5 to 10 years, we take the last good idea and then we give it a different name. Now, the problem with any type of good idea is that it starts to get popular. The more popular it gets, you end up with everybody's doing it. And you know what the problem is when everybody does something? It's kind of like agile. For those of you who's in an agile, who's in a company that calls themselves agile? Let's ask it that way, all right? Most companies call themselves agile, all right? Now raise your hand again if you think your company is actually agile. Okay, I'm getting maybe like 1/10 of the hands that are going up. So that's kind of the thing with microservices. It's become this very popular term that everybody needs to have on their CV. So, oh yeah, we're doing microservices too, just like everybody was doing agile a long time ago. Now, a lot of times the contrast, the why are we doing agile, why are we doing microservices, you know, the problem when something gets too popular is that we kind of lose rational discourse around it. So imagine if I came to your company and I said to one of the management guys, I said, you know what, you guys, you're not really agile. Are you saying we're fat? Right? Agile is such a good thing that the alternative is being fat and slow and ugly and all those types of things. And that's kind of how we've ended up with microservices as well, is that everybody needs to have the microservices brand, where the alternative is the bad, big, monolithic, everything in one place, in short, fat. So we're like, oh, no, monoliths, those are bad. We don't want to do any of those anymore. Instead, we're going to repackage things in such a way that now all of the different pieces of code are in their own processes. And look at me, microservice, right? So we got bad on the one hand, which is everything monolithically together, and then we've got good on the other hand, where everything is these small, tight, little Dockerized containers orchestrated with Docker Swarm or Mesos or Kubernetes or some other new fancy technology that nobody can pronounce. And we're like, yes, this is it. This is the future. We're going to be so agile and scalable. Netflix, watch out, right? But looking at this picture for a second, how is the coupling any different? I mean, is the fact that I'm doing the call remotely, JSON over HTTP, does that magically make my coupling disappear? How does that actually change the quality of my software? And I got a short answer for you. All of this microservices stuff, it's not going to make your coupling any different. All you're doing is rearranging the mess that you've got. If you have kids, I have kids, 4 kids by the way, it's like asking them to clean their room. They don't actually clean it, they just sort of spread the mess around differently or shove it all in the closet. That's kind of what we do as software developers when we're doing some sort of re-architecture effort, is we take all the coupling and kind of spread it around and hope that nobody notices. Sprinkle on some nice Docker over the top of it. It's kind of putting like a carpet on top of a mound of dirt. And there you go. Your microservice is ready. Now, some people will say, no, you can't do it that way. Obviously, you've got too much coupling between your services. What you need to do is you need to put all of the data that you want to transmit in some database, and then you call the other microservice and tell them, hey, okay, you go do something with this ID. They'll go to the database, read out the data that they need, and presto changeo, coupling disappearo. Right? Look at how decoupled my microservices are. I'm only sharing IDs. My APIs are never going to change. Now, we've heard, you shouldn't share databases between microservices. So yeah, doing that, that's a bad thing. But then people say, hey, maybe if we put a REST service around the database, nobody will notice. Right? That's like putting a carpet over the mess in our room. And voila, microservices. So let me summarize this whole microservice, how you're doing it wrong thing. Bottom line, services, micro, macro, micro, or otherwise, are not about remote calls. That is so important, I'm going to say that again. Microservices are not about remote calls. Calling something remotely does not change any logical coupling. So I know I'm flogging a dead horse here, and if you've seen me talk before, I've mentioned this over and over again, but I keep seeing it happen over and over again. So, this kind of thing that we were talking about before, where you've got one process calling another process, remotely calling some kind of code, that's not a service. Similarly, if you put a REST API around a database and call that remotely, that's not a service. If you host everything in Docker, Kubernetes, Docker Swarm, all that kind of stuff, containerize it, run it on Azure Stack, scale it up, down, inside and out, that's not services. So you're saying we're fat, right? Ultimately, it comes down to logical coupling. We need to have services that are fundamentally decoupled from each other. We need to hack away that chain of logical coupling, and it really is a great deal of effort. It's not the kind of thing that you can just sort of spread the mess around differently. So, let's talk coupling, starting with layers. Who doesn't love layers? I don't love layers, by the way. So, layers. What we've noticed over and over again is that with all of these layers, the business still comes to us and says, you know what? I need another field to appear on this screen. And then we're like, okay, so I add that field to the database, and then I add that field to my mapping logic in my ORM, and then I add that field to my domain objects, and then I add that field to the DTOs that are exposed by my API. and then I add that field to the view model, and then I add that field to the view. I say, that's maintainable code. Right? You know what I need? Code generator. Who's ever built a code generator to do one of these things? Come on, raise your hands. Those of you who raised your hands, who would do it again? Yeah, I got a couple of hands up there. You must be consultants. Then you got some people come along and say, you know what the problem is? We don't have enough layers. Right? 5 layers wasn't enough, right? We started with 3 layers. Remember the good old days where it was client server 2-tier? Then we moved to the 3-tier architecture, and that wasn't enough. And then it was N-tier, because once we realized 1, 2, 3, we better just abstract this away to N. Right? We're good at doing that. So we add layer after layer after layer, some anti-corruption layers so that we can say that we're doing DDD. Right? Who likes doing DDD? Yeah? Okay, good. The problem is you will have this kind of coupling top to bottom no matter what. We've tried for roughly 20 years, since the early days of client server, to somehow get that coupling to disappear. It's never worked. And this is one of those moments where we kind of need to move through those 7 levels, or maybe it's the 12-step process, where in the beginning there's denial. What do you mean there's coupling? There is no coupling. It's all encapsulated. Step 2, anger. How dare you say that there's coupling in there? And gradually we move through grief. Oh my God, I can't believe I have all of this coupling. And finally, there's acceptance. Yes, there is coupling. It's a fact of life. Move on. But I'd like you to take a step beyond just acceptance. Go into kind of a Zen state. Be one with the coupling. Truly embrace it into your being. And from that state, you might have an epiphany. That while there is lots of coupling top to bottom, when we look side to side, sometimes there isn't very much coupling in there at all. That bits of logic that deal with, say, a product's price couldn't care less about the number of stars that the product has, and vice versa. That the bit of logic that deals with the customer's shipping address really couldn't care less about what the customer status is. So yes, this is related to customer, and that's related to customer, and this is related to product, and that's related to product. But when we look more deeply into the transactions that are operating through these entities, we kind of realize, you know, we just sort of lump them together by convenience. What if we split them apart? What if the services that we were looking for were never a layer? Maybe there are these kinds of vertical slices that just kind of happen to have a lot of the same layers with each other. And we can take them apart not only at the business logic layer and at the data access layer and at the API level, we can go all the way up to the UI and say even a single screen that we're looking at, even a single controller that we might have written in the past, maybe that's not actually a single controller anymore. Maybe the product catalog pieces, the product name, the description, the image, that's in one service. And the ratings are in another service. And the price is in yet another service. And the inventory is yet in another service. And yeah, they're all associated by the same product ID, but realistically, when a customer is making a purchase, we don't need to know what the image of the book is. When we're replenishing the inventory of a product, we don't need to know how many stars it has. There's lots of stuff over here that both at a UI level and a business logic level can really be kept apart. Now, if you want to see what it's like to build this type of composite UI, I've put together a kind of holding your hand model. So I'll put this up, bit.ly/particular-microservices, to show you how you can do this type of composite UI with Angular. Now, there's a whole bunch of other stuff in that GitHub repository, so feel free to kind of go around in there. There are a whole bunch of exercises. But it'll give you a model where you can see what this type of micro view slash microcontroller UI type of thing, how you can build something like that, and then how to flow that type of decoupling all the way through to your back end. Now, the same as, and again, this is sort of an easy UI to look at because everything kind of has its own widget that is laid out separately on the page. But we can take this a step further and arrange these types of things in a grid as well, where we've got product catalog and image information as sort of one part of the grid, and then ratings as another part of the grid, and prices as another part of the grid. So we can do this exact same model even though the layout is kind of more intertwined, and you'll see that also in that bit.ly link that I showed you before. Now, where this leads us to is an important conclusion about what the term service means and it doesn't mean. So when you think about it, in the browser, we're going to have JavaScript code, that Angular code, those Angular modules, from a whole bunch of microservices. We're going to have the yellow microservice that's telling us the product catalog information. We're going to have the orange microservice with its bit of JavaScript in the same browser telling us about the price information. We're going to have that gray microservice that is showing us the information about the inventory levels. So in essence, when we look at the runtime environment, a service isn't necessarily running by itself. It's running alongside components from other microservices in the same host. And that's not just true about the browser. The same thing can happen on the web server. So if we're doing server-side composition rather than client-side composition, the same type of thing happens. Very often what we'll see is that we will be taking a component or two from service A with a component or two from service B and putting them in the same process. And the same thing when we look farther back from the web server into app servers or any type of logic like that, you'll very often see that these type of logical microservices are not physically deployed by themselves. In fact, most of the time, in order to do any type of UI type of work, we're going to need them to be hosted together. So, beyond just the hosting side of things, I'm going to get back to that in a little bit. I want to talk about the data side of things. So, yeah, you might have heard of terms like polyglot persistence that I'm kind of illustrating over here, where one microservice has a SQL database and another microservice is a sharded database and a third one has a graph database. The important thing here is that these services own their data entirely. And that means a lot to actually own your data. Because a lot of times there's that element, as we said before, of, okay, we're not going to share a database, but then we end up just sending all of our data from one microservice to another via an API call. So the fact that we're not talking through a database, but we're sending effectively all of the business data via an API call, we've still shared our data. We just didn't do it via a database. We did it via an API call. So when we say that services own their data, what that means is that the data remains encapsulated in that service. The service doesn't share that data, doesn't send it out to other microservices. And that means not by an API call, not by a shared database. And for those of you that are using some kind of publish, subscribe, event-driven infrastructure, same thing. Not going to be sharing all of that data via an event mechanism. So yes, these types of highly encapsulated services can pub-sub with each other and will need to pub-sub with each other. But be very careful about the amount of data that you're transmitting across. Ideally, you want to be sending nothing more than some identifiers. So an identifier, maybe a date time, something like that. If you start sharing data that's volatile, like a price or an address, that's when you start getting into trouble. And again, the issue here is not about how you share it, but the fact that you're sharing it in the first place. So this element of encapsulation is super important. That's the #1 touchstone of logical decoupling. You want to decouple things, don't share so much stuff between them. Now, the other area where people kind of get a little bit thrown off about microservices, and this is where microservices ultimately meets the SOA done right, it's not just about a single system. Because what we're looking at so far might give you the impression that we're designing microservices for system A in and of itself without taking into account anything else in the organization. But we need to take a much wider perspective. The problem that we have, and this isn't entirely our fault, this is how IT as a whole is structured, is that your team is given a project, and that project is to build one system, and that's what you focus on for the next year and a half of your life. And whatever other teams and other projects are going on, it's like, well, they do their own stuff. And if you need to integrate with them, okay, so you call their API, they call your API. But really, we tend to have our blinders put on. In order for us to have proper and complete data encapsulation, we need to look beyond just one system. We need to look across the entire enterprise for all of the different kinds of systems that are there. And oftentimes what we'll see is the exact same data is used and modified in a bunch of different systems. So if we're talking about price information, yeah, it's going to be available via mobile app, and that's going to be available in our backend, and that's going to be available over a portal, and that's going to be available in a kiosk application. The same data ends up traveling across all of these systems. So if we're going to say that a service owns its own data and doesn't want to share it, then the only way that something like that's going to work is that if our services extend beyond the boundary of a single system, such that if there's price information, there is one service that owns that, whether that's in the mobile app, the kiosk application, the single page application, the internal Oracle Forms finance thing that we've got. Services as a logical construct own their data wherever it may be, even if those different systems are written in different programming languages. So it doesn't matter that the mobile app is written by iOS developers, and the portal is written by Java developers, and the backend is written by .NET developers. The focus here is on logical ownership. So as you can understand, where that's leading to is that if we have a team that is focused on a microservice, then that team will likely be made up of developers that have Objective-C knowledge, .NET knowledge, Java knowledge, JavaScript knowledge, and all of them need to work together on that same business domain. Now, where this leads us to is kind of a very different state with regard to our systems. Because after we've taken out all of those components, so the part that deals with the price, and the part that deals with the address, and the part that deals with the product name, and image, and description, and inventory, and the ratings, really what's left of the system? In essence, the system kind of becomes this green Lego board, if you will, that we take a red Lego brick from the red service and a blue Lego brick from the blue service. And we arrange all of these things together on that platform, but that fundamentally the system doesn't really have its own code very much. All of the code is belonging to the services. The system doesn't really own its own data. The data is owned by those services. And if you follow that model, you'll end up with a very different style of architecture, and that's actually what's going to give you the benefit of microservices. Because that way, when you make a change to the blue, you're not going to break the red, because you're just not sharing stuff between blue and red. And when you make a change to the red, you're not going to break the yellow, et cetera, et cetera. This is what makes doing microservices / service-oriented architecture done right hard. Because ultimately, it's different from everything that we've been doing so far. Kind of like Agile, right? If you want to get the benefits of Agile, you got to work differently. Just as a quick anecdote, I was at a client maybe a year ago that was doing Agile. And I sat in one of their stand-up meetings. It was hilarious. Everybody was standing up. Everybody was saying, this is what I did yesterday. This is what I'm going to be doing today. This is what I'm blocked on. But nobody was listening to anybody else. Everybody was just kind of on their phones in the stand-up. Oh, my turn? Yesterday I did X. Today I'm going to still do X. I'm not blocked on anything. And they went back. Look at me agile, right? If you want to get benefits, you need to do things differently. The same thing with microservices. A lot of this stuff, it's a fundamental architectural shift. And that doesn't just happen overnight. Now, that's all of the microservices stuff. Now I want to tell you where this type of model kind of runs into difficulty. So this model does break down, unfortunately. You can have a high level of encapsulation, but invariably you'll end up with some slightly more complex business domain where you're going to try to keep things all separate and encapsulated and not sharing data with each other. And then there's going to be the sense of, but I can't. I have to send data across. And that's what I'm going to be talking about for this second half of the talk. It's where this type of encapsulation runs into problems. So, starting with search. Who needs to do search on their system? Yes? Search. Okay. So, the problem with search, well, there are multiple problems with search. The biggest problem with search is that Google has spoiled the world, right? The average user picks up their phone, types in some random crappy string of text that isn't even correctly spelled, and Google, in sub-second time frame, knows what they meant to search for and finds the most relevant result for them, and it's just there on their phone. They're like, oh, great. Once upon a time, that was considered magic. Once upon a time, people appreciated just how hard it was to do something like that. But after you've gone through that process as an end user 50 times a day for the past 5 years, you just kind of expect it. And then they turn around to us and say, I want search. We're like, okay, did I mention that I'm not Google? Did I mention I don't have 20,000 engineers and 100,000 servers and a data set from all of the users on the planet searches over the past 20 years? They're like, I'm sorry, I tuned out after the part that you said Google. I was looking something up on my phone. They just expect us to do that. So here's a small tip. Don't try to recreate the same level of magic that Google has. You're not going to succeed. So one small thing that I want you to know about search, for those of you, because a lot of you are trying to do search, okay? Understand that search is not just about the free text search. There's this important part called relevance. If you have a data set that's large enough, then your users want relevant results, not just matching results. Here's relevance in a nutshell, 30 seconds or less, what you need to do to return relevant search results. Ready? Go. Every time the user clicks a search result, you need to increase the relevance of that result. Every time they click back and click on a different search result, you need to decrease the relevance of the previous click for all future searches. Anytime they do a text search and then they change the text again, you need to reduce the ranking of all of the results that you showed them for both of those text search results. Are you getting an idea of how hard this stuff is? That will give you Google as of 20 years ago in the best case. All right? This stuff is damn hard. Now, what I'm going to be talking about here is a different category of search. For example, a product-specific search, where users want the ability to say, okay, I'm looking for a product, let's say it's a watch, and I would like to see watches with a blue face on them. I'd like to see them made out of metal. I'd like the price of the product to be, I don't know, between $100 and $200, that kind of search. Now, the issue that we have with this kind of search is that, well, now I'm dealing with colors, and I'm dealing with the metal band or the leather band or in the color of the band and how much it costs. And while historically I would have said, hey, color is in one service and the manufacturer of the watch is in another service and the price is in another service, all of a sudden I got this search that needs to operate across all of these fields. Now I have a problem. How do I keep my, up until now, separate microservices from becoming entangled again? Let me give you another problem. Customer-specific pricing. So there's this new thing, it's called the internet, you might have heard of it, where users can't see the prices that other users got. So we can actually charge different people different prices for the same product. Isn't it awesome? Now some of you in Europe might be saying that's against the law. Which is why e-commerce goes so well in North America, and you don't really have really strong e-commerce plays in Europe, or not the same level. But customer-specific pricing is that same kind of thing where in the past we would have said, sure, a product has a price and a customer has an address. But then someone in the business says, you know what? Customers in Oslo, they're a rich bunch. We can charge them more. Customers who are living on the outskirts of Oslo, we'll charge them a little bit less. Customers who live way up north in Norway, we're going to charge them in deer pellets. So this element of saying the customer's address is now going to influence the price that we show them. Or for example, this customer bought a lot of stuff from us, we should give them discounts to keep that flywheel spinning. This customer hasn't really bought very much from us yet, so don't give them any special discounts. Unless it's Easter. And then in Easter, we're going to have some other kind of special promotion that's going on. Once again, what started out as a nice, simple separation where, sure, customer addresses are in service A and the product price is in service B, and all of that kind of stuff, very nice, cleanly separated. And now we get these requirements from the business and they're saying, nope, sorry, you got to tangle it all back up together again. I'm going to give you a third category just to make sure, because everything needs to be done in threes. Fraud detection. Fraud detection, something that's very important anytime you're dealing with money, and lots of business systems end up dealing with money somehow. So let's talk about fraud for a second. Fraud is one of those really difficult types of domains where once again, the business starts looking at all sorts of weird patterns. So for example, let's say, this customer, all they've ever bought from us is books. And then one day, out of the blue, they're buying a fridge. Now that wouldn't be so odd, but the shipping address that they've selected from the fridge is different from all of the other previous books. We've all sent them to a different address. And on top of that all, the IP address that they're using for making this purchase is out of Nigeria. So we're getting to this point where we're saying, something weird is going on here. Maybe we should flag that as a potential fraud and ask the customer to approve it via two-factor authentication on their phone. So whatever these types of rules that we're dealing with fraud are, again, I hope you're getting that impression of we're going to get these categories of requirements that say data that would have been nicely separated between different services now kind of ends up intermingled in a bunch of different places. And that's really the problem with most type of architectures, is that in the beginning of the project, because we're nice and agile and we want to focus on, you aren't going to need it, just ship it, focus on agile delivery, we usually tend to pick the simplest, easiest requirements at the beginning of the project, right? And then we deliver those and we feel good about ourselves, and then we pick some more simple requirements and then we deliver those. And after a year, we finished all of the simple stuff and we're feeling good about ourselves. And then we start having to deal with these kind of more complex ones. And that's the issue, that we get blindsided by this complex domain, And by that time, we've already kind of put a whole bunch of puzzle pieces together, and now we have just a bunch of puzzle pieces, and they just don't fit. And we keep trying to kind of turn the microservices around and say, maybe if we do this, and maybe if we publish that event, and maybe if we do this UI composition. Eventually, you kind of just throw up our hands in there and say, look, it would be faster to write the system from scratch than to implement these requirements on top of the existing code base. At which point in time, people saying, what, microservices didn't do it for you? And your answer is, the solution is actors. Everything needs to run on Erlang. That's how you build the next WhatsApp and get bought by Facebook for $19 billion, right? So how do we go and do that next project on top of actors and Erlang? Again, we pick the simplest possible requirements and go through this process over and over and over again. Only this time, where are my consultants? Who's the consultants in the room? Raise your hand if you're a consultant. Then we go do it at another client, right? We can rinse and repeat the exact same practices over and over again, only this time it needs to be written in F#. Why? Because I don't have F# on my resume yet. Right? Gotta stay current. But we're back to the fundamental problem that how do we build these requirements? How can we prevent creating a tightly coupled mess when the requirements seem to force us into that position of tying everything back together again? So, this is not just the talk where I say, sucks, doesn't it? Have a good conference. Right? Or, I used to be a consultant, if you want the answer to this question, you're going to have to hire me. There is a way out. And I already told you what it's going to be right at the beginning of this talk. Rules engines. Now, who's heard of rules engines before today? Okay, most of you have. Who's used a rules engine in the past? Okay, fewer hands are going up. Keep your hand up if you enjoyed using a rules engine. Okay, I've got one out of a room of maybe 300. Okay. You're the same one that liked to do the code generation, right? Now, the thing about these rules engines, again, a long time ago, rules engines got really popular. And then, they fell out of fashion. Kind of like service-oriented architecture. So I figure it's just about time for a rebranding of rules engines. Maybe we should call them micro rules. Right? What do you think? You think that domain is taken? Somebody check that for me. Right? That's how you know how to brand something. First you check if the domain is taken, then you find out it is, and then you come up with a different name. Right? So when talking about rules engines, I want to talk about rules engines not as like a full-blown rules IDE that you're dragging and dropping things and authoring all sorts of crappy stuff in XML, and not that kind of rules engine stuff. I'm talking more at the level of design patterns. So you might have heard of the Gang of 4 design patterns or patterns of enterprise application architecture, all that kind of stuff. That's what you need to think of. It's a pattern of implementation where you want to have this kind of decoupling from the rules engine, the sort of generic piece of infrastructure, and the rules themselves that are executed by that rules engine. That's in a nutshell what we're talking about here. So some type of generic infrastructure that you can plug into from different services. So let's start with that search that we were talking about before. Fundamentally, this search process can be thought of as a kind of filter or a collection of filters that gradually take different steps along the way and say, okay, first thing we need to do, out of all of the product IDs, let's do some free text analysis and see what are the product IDs that match that. From there, let's go through a different rule which filters out the products that have the right price, or filters out the products that have the wrong price. And then we go look at the brand of the product that they've selected, and then we look at the color of the product that they've selected. But the thing that I want you to think about over here, and that's the important distinction, is that this search engine, not search service, this search engine, what it does is it allows each microservice to put a component into it, and then that search engine will run that set of rules. So in terms of just regular software design, imagine if there was an iFilter product IDs interface. And each of those services wrote a component that implemented iFilter product IDs. That's really all that we're talking about over here. A generic type of search interface that is implemented by each one of those microservices. And then we take the component from red and the component for blue and the component from green and the component from yellow, and we put them all in this generic search engine. And that's what allows us to be able to have this kind of search, which is taking into account price and color and brand and all that kind of stuff, without creating any additional dependencies. Because now the thing that's dealing with price doesn't need to know about the color, and the thing that deals with the color doesn't need to know about the brand. Each microservice can remain largely autonomous. But again, what we're talking about here is not the whole microservice, but the search component of that service. Right? So when you're thinking of how you end up building this kind of stuff, it's one component out of that service. And once we get all of these search result IDs that kind of filter out the very bottom of this, then we can go back to the grid that we saw from before and say, great, now I know these are all the product IDs that match that. Let's do that same UI composition from before, where we're going to have the blue service that shows the product catalog information of the images of the book and the names of the book and the authors of the book. And we're going to have the yellow service that's showing the ratings, and we're going to have the green service which is showing the prices. So that way, the search engine doesn't necessarily need, in and of itself, access to all of the data directly. I'm going to reiterate that. The search engine is generic and doesn't take a dependency on all of that data. All it's doing is generically calling and looping through all of these iFilter product ID interfaces. So, search. Check that box. Let's talk about customer-specific pricing. We can follow that same sort of model, just with a slight twist, where we have one component that provides us the list price. So how much would this product cost if there were no discounts and none of the other customer-specific pricing? So what we'd have here is not a price service, but a pricing engine. A pricing engine that exposes interfaces that each service can plug into. So after the search, after that pricing engine gets that original list price from the I provide list price interface, then it loops through all of the implementations of I provide price factor. So what we have here is a type of model where instead of the special offers saying, okay, what we're going to do is decrement the value by X, instead it's better to operate at the level of a multiplication, where each of these components is giving us a price factor. So based on the Easter special offer, that's 10% off. Based on the fact that the customer lives in Oslo, that's 20% more expensive. The fact that this customer has purchased a lot of stuff from us over time and they qualify for something there, that's 25% off. And the nice thing about this type of multiplicative factor, it doesn't matter which order we run the rules in, right? In other words, if you take $10 and then you multiply that by 0.9, and then you multiply that by 1.2, and then you multiply that by 0.75, it doesn't matter which order you're doing that multiplication in. So once again, that pricing engine can largely be agnostic, which services are providing the rules and what are they doing and what order do those rules need to be run in. So what comes out at the other end is a price that is $8.76. And the average user would look at that and say, that's an oddly specific price. Right? I can't imagine that there's anybody in that company's back office that decided that this product should really cost $8.76. But that's that customer-specific pricing in action. So when looking at these types of engines, always try to think when you're designing them, this is just a design pattern. What is that interface that they're going to expose? And how can you set it up so that it doesn't really matter which order the rules are executed in? So that's customer-specific pricing. Let's talk fraud detection for a second. We can do the same kind of thing, where there's some base fraud score that everything starts from, let's say 1.0, and then we have information about the shipping address. And then we can say, oh, okay, if the shipping address is in Nigeria, but the customer's regular address is in Oslo, Norway, then that increases the fraud score by 200%. And then we look at the credit card information, let's say where the credit card was issued, and the IP address of where it's currently being used from. Say, okay, it seems to be being used from some place in the British Isles that is a tax haven. Say, well, I don't know. Maybe this is fraud. Maybe this person just decided to move to someplace in the middle of nowhere for tax reasons. But let's increase the fraud score a little bit. Let's make that, say, 25% bigger. And let's look at the order history. What type of products have they bought in the past? What type of product are they buying now? And again, each service with its own data has its own fraud component. And again, it's not looking at what any of the other services are doing. It's just saying, based on the data that I have, how much am I going to increase or decrease this fraud score? And then what comes out at the other end is that based on all of these generic I provide fraud multiple rules, the fraud score ended up being, I don't know, 126. And because that number is greater than some threshold that we've defined, therefore, we're going to require two-factor authentication. So again, what I want you to take away from this is that even though we get requirements that say fraud, pricing, search, all require data from multiple services, the way that we resolve this conflict in terms of the coupling is by recognizing that search isn't a service, that pricing isn't a service, that fraud isn't a service. Rather, it's a composition of this generic rules engine type thing and all of the components from all of the other services that are plugging into that. Again, I want to reiterate, the reason why this works, the reason why this holds up, is that a service isn't necessarily a runtime separately deployed component. The way you need to think about services is they are a collection of components where some of these components are going to be deployed together in the pricing engine, and some of these components are going to be deployed together in the search engine, and some of these components are going to be deployed together in the web front end for just doing some UI composition. The service is not a unit of deployment. I said that earlier in the talk, I'm saying it again. A service is not your unit of deployment. You take these components from multiple services and you create a process. That is your runtime deployment, the process, not the service. There's this many-to-many relationship. A given service will be deployed to multiple processes, and in a given process, you're going to have components from multiple services. If you follow those two separate degrees of freedom in your architecture, you will be able to avoid creating all of that logical coupling mess that we talked about before. So, just want to add some really small bits of stuff just from the framework design perspective. what you're going to want to have in these generic engines is some code that at startup of that generic frameworky process, you're going to the runtime directory of that engine and say, okay, find me all of the assemblies which are over here. Scan each one of those assemblies, see if there are any types in it that implement I provide price factor, I provide fraud multiple, I filter product IDs, whatever that generic interface is for that specific engine. And once you have all of that, then in essence, when you want to plug in more rules, all you need to do effectively is to drop another assembly in the runtime directory. Now, you may want to add later on some more management around this to say, well, what rules are running in each one of these places? And that's when you start moving out of, say, this sort of really generic design pattern type of world into more proper rules engines with management and the ability to turn on or off a given rule in a given place. But you don't need to start with all of that heavyweight infrastructure. It can really be as simple as a loop at startup, scan the assemblies, scan the types, find an interface. So, I hope I've given you some idea about how that really old rules engine approach can be connected to the more modern microservices approach and really help get rid of a lot of the coupling that we would have otherwise had. Now, my guess is that you still have a ton of questions and you're wondering, all that sounds great, but how do I do this in my domain? So, if you want to find out how to find microservice boundaries and how to combine all this stuff together, I've got a 5-day course, and you can sign up for that. My guess is that most of you, you got to go to NDC Oslo, that's kind of it. So, what I have is a bunch of videos from that 5-day course available at that URL, goparticular.net/NDC17. So go in there, sign up, and you'll get videos that go through a lot of these types of patterns and practices in a lot more detail than I can cover in just the 54 minutes that I have over here for you. If you do have questions, feel free to come up and talk to me afterwards. Once again, my name is Udi Dahan. I'm on Twitter at Udi Dahan and working at Particular Software, and we try to make building these types of really complex business systems easier, whether it's through these types of talks, the types of videos that we have available, or infrastructure that enables building these types of loosely coupled systems better. So have a great rest of your conference. Thanks for having me, and have a great day. Bye-bye. Thank you.